Welcome to this next video discussion as part of the RICS Tech Partner Programme. My name is Andrew Knight and I've been working here at RICS for over 12 years. I sit within the knowledge and practice part of the organisation, and my role is to look at the impact of data and technology right across the built and natural environment, and with over 110,000 members worldwide working right across the property life cycle through land, planning and development, construction, brokerage, valuation, finance, building and asset management, property management, and building surveying, just as an example. It's obviously a hugely broad and rich canvas upon which data and technology is having a profound effect. And indeed, our members also work across all the different asset types: land, residential, commercial, alternative, and infrastructure. So once again, a very, very broad spectrum of activities that our members are involved in. And today I'm really excited to have Mike join me from Herotech8. So welcome to the call, Mike.
Hi, Andrew. Thanks for having me.
Pleasure. And I always like to start the kind of technology conversation with a kind of bit more of a human element. So it's always great to have a bit of a backstory in terms of how you've come into Herotech8, and indeed how Herotech8 started and how the technology developed.
Yeah, sure thing. I'll try and keep it as a short intro as I can as possible. It's been a long and winding road to get to where I am today. So yeah, my name's Mike Edwards, obviously head of business development here at Herotech8. My background, I did a physical geography degree at Aberystwyth University, specialised in geographical information systems, predominantly back then around glaciology, and then following university, never had any use for that degree whatsoever up until very, very recently, and I'll come back onto that a little bit later on. But yeah, so I then pursued a career in renewable energy, installing solar PV and ground source heat pumps, and then quickly turned my attention to infrared thermography, so doing thermal surveying of domestic properties and then into commercial properties, initially looking for heat and energy loss, and then quickly started getting heavily involved in troubleshooting of buildings, for want of a better word, using infrared as a way of diagnosing and identifying building defects, and typically latent defects, stuff that you wouldn't be able to identify with the naked eye. Yeah. Fast forward to 2014, then I first started working with aerial drones. So that came about by strapping a thermal camera, a handheld thermal camera, to a very early model drone. It was a bit of a Frankenstein's monster back then. And yeah, we believe at the time we took what was the first fully radiometric infrared image from a drone, and that was a bit of a light bulb moment for me in drones as a tool to put the right sensor into the right space, remove humans from hazardous environments, whether that's working at height or whether it's confined spaces. It was very much a eureka moment for me in my career to then identify, with this technology, I can enable a lot more asset stakeholders to use drones and use drone data far more readily. And so that sort of took me on a journey of various startups and working with other sort of joint ventures over the next few years. To fast forward in 2020, I was managing a fleet of around 60 drone operators with my previous business that I'd started up. And those operators were dotted all over the country. They all had different areas of expertise, but as is the nature of the drone industry, all were a bit of a jack of all trades, master of none. I've got a tool that is a little bit of a Swiss Army knife. I can try my hand at aerial media and photography, but I could also probably do a topographical survey. And so I was working very heavily in the drone space, looking at, as you in the intro you mentioned, the RICS is a broad spectrum of specialities and applications and use cases, very similar with the drone industry. And so my frustration was in trying to get the right personnel to the site with the right equipment, with the right insurances, with the right expertise was a nightmare, especially when you factor in our notorious UK weather and making sure that they're there with the right environmental conditions. So I started thinking about, well, how could I provide a more robust service to my clients and provide them with drone data as and when they need it, and do it on a much higher frequency basis, whilst also reducing the operational cost and resource burden of doing so. So I set out about looking at what technology was out there for installing drones on site so that I could personally operate them on site myself from a remote location. I looked at different systems that were being developed in the US and in Israel in particular. There's a few companies out of Israel that have been going for a good few years now, but a lot of them were very conceptual, or a lot of them had designed and manufactured a drone infrastructure from the ground up. So they had made their own drone. Whereas at this point, we've become very familiar with the DJI systems and their capability. And so a lot of our clients wanted to stay with that type of platform, but wanted the automated remote functionality. And that's when I came across Herotech8. And Herotech8 was the only organization who could physically demonstrate an infrastructure that I could install on a construction site and that I could operate it from anywhere in the world over the internet. And so that's how I first came across Herotech8. Fast forward 8 months later, I exited that company and asked for a job at Herotech8, and here I am now head of business development.
And from the context of Herotech8, what sort of industries and sectors you currently work with, and where are your systems currently deployed?
Yeah, so Herotech8 was very much born out of the defence sector. So it's through DSTL funding is how we were initially conceived, and security and security and emergency response and surveillance has very much been at the core of our business, where we are manufacturing our systems. We'll work with a security organization or with an asset owner who's looking to protect that asset, and we will install the infrastructure and train personnel on how to use that. And those systems now are deployed all over the world. We have systems in Malaysia performing border security. We have systems in Abu Dhabi in the Middle East performing security around the world's largest solar PV farm, as well as providing maintenance and operational services to that site. We've obviously got various sites across the UK, but also in Europe as well, in France and Germany and elsewhere. Predominantly, like I say, the focus has been around security, because the ability to have infrastructure on site, a mobile CCTV camera, if you want, that is able to patrol a site at pre-programmed time intervals, or can react to an intruder alarm or any other type of perimeter protection alarm. We can integrate with those systems and get the drone to automatically deploy. So it's lent itself very, very well to the security space. However, with my background and the applications I was looking at, very quickly over the last sort of 18 months, 2 years, the business has started working. A significant amount of our time now is with construction, with main contractors and with property consultancies, where we're now not just installing the system for any one particular use case. It's embedded within a site and it can be utilized by all stakeholders within that, who has an interest within that site. So whether you're a surveyor looking to carry out a site visit to inspect the quality of a steel frame that's been erected, or whether you're a civil engineer who wants to quantify what volume of aggregate do I have on my site, and can I use that volume of aggregate to fill a hole I have elsewhere on site, or whether you're the marketing manager who wants some pretty pictures to put on LinkedIn. Now, all of those stakeholders can simply go onto our open air platform, which I'll explain a little bit later on, and request these flights, and the drone will automatically deploy, capture the data that's required, controlled by the expert, and then you can view that footage in real time or wait for it to process and then gain access to it within a couple of hours.
So, I mean, from your perspective, obviously you've mentioned a couple of use cases there around the way that surveyors and property professionals can use drones today. Are you seeing some other particular use cases? And I guess really interestingly, do you feel that we've seen the level of adoption that really is deserved given what the technology can do now? And so, where are the gaps? Where are people using drones and where aren't they?
Yeah, it's been really interesting to not just watch, but to be having been involved in the evolution of drone technology, public's perception, but also industry's perception and their willingness to adopt it as another tool in the toolbox. And I've seen a number of large multidisciplinary organizations really struggle to understand how can we exploit this technology and how do we embed it in our day-to-day, because there are a lot of inherent risks with operating a drone, and rightly so. Hence the struggles of the Civil Aviation Authority and how we regulate our airspace in the UK. When you have so many people wanting to utilize this technology, it generates a lot of risk, and therefore rightly a lot of organizations are quite risk adverse to what the technology could expose them to. So there's been that battle over the last decade between what can we use this technology for and what threats does this technology pose to us. And I don't mean necessarily just as a drone as a threat to your site, but if we operate drones or if we subcontract the use of drones, what are the potential implications on our business? And so I've seen a number of organizations who've gone to an outsourced resource. They go to a specialist provider to get their drone services, who would then perhaps later bring it in-house in some capacity. But in both scenarios, whether you're outsourcing or insourcing your drone operations, I have definitely noticed and continue to notice a real lack of scalability in those operations. And even with some of the very well-established drone fleet teams that are out there with some of our critical national infrastructure and some of our major contractors, they are using the drones much more readily now. But because they are such a drain on resources, that you need somebody in the field operating that drone, and very often, if you take the construction scenario, it's typically a civil engineer or a site manager. And funnily enough, I was just on a call with a major contractor this morning, and it's actually the regional managing director who is the drone pilot for the organization. They're the one that's gone through the licensing training, yeah. And therefore, exactly, yeah, and they're now the ones going out site to site, taking aerial photography and doing site automosaics to put on LinkedIn and for site progress monitoring. And when you think that the majority of the use cases for a drone on a construction site, for example, are automated. You want a map creating of your site, you create a polygon of the area you want covering, and the system will automatically generate you a flight path and capture the data in an automated fashion. You power it on, you might need to change the battery over halfway through, but otherwise you're pretty much there twiddling your thumbs, waiting for it to finish and land back at your feet. Now, that for an organization is a very big expense. The drone itself isn't a big expense. The data processing isn't a big expense. It's the resource to be on site to do that. Yeah. And so our focus has been very much around how can we reduce that resource burden? And by treating the drone as a robot, which it is, and integrating it with infrastructure, which is what we provide, suddenly all of these stakeholders can access that much more readily. And suddenly you have a means to scale the use and the exploitation of drone technology that isn't going to be a burden onto your business and isn't going to be a risk. And what we're seeing by having done that is building surveyors and site managers and marketing managers are now all engaging with drones on a much higher frequency basis and are getting much more out of that data. When I was first starting out, you would talk to a building surveyor about photogrammetry and the use of photogrammetry for generating topographical maps or 3D models of buildings. Photogrammetry at that time was seen as is this a technology that we can trust? We're not sure. It took a good sort of 5-6 years before people would start to trust photogrammetry. I went through exactly the same process back in 2011 with infrared thermography. Everybody doubted it initially. Now there isn't a surveying practice out there that probably doesn't have an infrared camera somewhere in one of their offices, most likely probably gathering dust under somebody's desk, but they will be there and they will understand the value of it. So for building surveyors in particular, if you look at your typical RICS members, how you navigate regulation in the UK is a full-time job in and of itself. Yeah. And so RICS chartered institutions, organizations are having to employ people with specialist knowledge to then manage how you purchase drones, what type of drones is it that we should be purchasing, who within our organization should be flying these drones, how do we keep up their competency, how do we keep up their insurance and the maintenance of the drones. There's a real operational burden to them. And so we've seen a lot try, but those that have actually managed to scale and scale significantly is very, very few. So what we're excited about now is being able to put this technology into the experts' hands, but without them having to actually fly it, just let them exploit the data that comes from it. And once we start doing that, I think what we'll see is actually building surveyors as an example, or project managers or quantity surveyors, being able to use technology, not just the drone itself, but more importantly, things like photogrammetry, like neural radiance fields for generating very, very detailed photorealistic 3D replicas of the environments that they're interested in for contextual visits to a site. I think we'll start seeing technology like that also being adopted at a greater scale as an indirect result of a greater adoption of drone technology.
Indeed. And, you know, I know when we first met at another tech partner event at the Esri conference, you obviously had your drone in a box, literally. And I think you've almost, you know, really articulated why that is so powerful. So by having this drone in a box, you know, how are you able to fly drones safely? Because effectively you're doing this without being in line of sight, aren't you?
That's it, exactly. Yeah. So, you know, our entire business is built around the ability to fly a drone without physically being able to see the drone. So, in the UK, obviously, anybody that is aware of flying drones or has subcontracted drones in the past will probably be aware that you need to maintain visual line of sight with your drone at all times. If you'd like to fly beyond visual line of sight, you need to apply to the Civil Aviation Authority with an operating safety case for an exemption to that, so that you can say, under certain parameters, I can now fly my drone beyond visual line of sight. Every instance that we are deploying our technology, we will be flying beyond visual line of sight. So there's quite a rigorous process that we must go through with the regulator to get to the point at which we now have an exemption. So there is always a sort of a soft landing installation of our systems before it's fully integrated and fully operational. But fundamentally, how we are able to operate over the internet in remote environments is by using what I've already mentioned, is digital twinning. So digital twin, a term that gets thrown around a lot these days, and so I'm, you know, always err on the side of caution when using it. But what we effectively do is we use the 3D model of that environment, and we use real world sensors so that we're constantly able to update that 3D model of the environment, and then we simulate all of our flights. So before any mission is conducted remotely, we put the 3D environment into the Unreal Engine via the Esri platform. So we process all of our data using Esri SiteScan, and then we push that data set through our 3D digital twin of the environment into the Unreal gaming engine. Within that, we've built a drone flight simulator. But what we also simulate is what are the risks in that particular environment. So by monitoring in real time GPS or GNSS satellites, and also monitoring radio frequency from the communications module to the drone, wherever we are flying around that environment, we're able to risk model where we should and should not be flying at any given time, because the drone, in very much the same way if you're flying manually physically on site yourself, is susceptible to GPS loss or radio control loss if you fly behind an object or something like that. And that's obviously becomes even more of a factor when we are operating remotely. So by simulating first, we're able to firstly identify, are we going to capture the type of data that we want to capture? Really, really important to me is that obviously if we're flying, make sure that we do capture the data. When we're flying, make sure we avoid obstacles, and we can do that by avoiding those obstacles in that 3D environment, and then making sure that we're not flying into any high risk areas where we could be at risk of not just GNSS loss, but also things like wind turbulence, and when do we overfly a pedestrian area, for example. So by monitoring through the Living Atlas on the Esri ArcGIS online platform, we're able to monitor in real time how busy a road might be, for example. So we can then simulate when is the correct time to overfly that road. And what our system then does is, by taking in all of that real world information through the digital twin, we're able to then set parameters to say, only fly the drone if wind speeds, for example, are less than 30 miles an hour. So if there's a pre-programmed mission to carry out a topographical survey, and the drone cannot fly in wind speeds that, let's say, are more than 30 miles per hour, that mission will not be conducted. Our system has firewalls in place to prevent that mission from happening, and it will only then take off once wind speeds are below an acceptable threshold. So by building all of that into the front end, we are then able to fly arguably even safer remotely than you could do if you were flying just by taking off and flying around manually yourself.
So, given you've obviously been able to overcome to an extent the kind of regulatory issues around outside of line of sight, can you tell us a bit about the future flight projects that I know, the future flight challenge that UK research and innovation are running? Because clearly there are developments here to increase the ability to use drones for a number of purposes, but obviously that has to be done within some kind of regulatory framework, doesn't it?
Exactly, yeah. So the Civil Aviation Authority, they come under a lot of scrutiny over this, but they are, and when we can say honestly, because we are in constant dialogue with them, that they are working very, very hard behind the scenes to build a safe and robust, not just methodology, but again, it's an infrastructure for how can we integrate drones into the airspace when we have such a busy airspace on our little island. So the two things to consider that in the UK, we have both segregated and unsegregated airspace. The bulk of the airspace over the UK, despite popular belief that you own the airspace over your building, you don't. Pretty much all of the airspace across the UK is unsegregated unless you're within close proximity to an airport or a sensitive area like a prison or a port or something like that.
Yeah.
Those spaces are segregated. And Herotech8 have a very strong track record of gaining beyond visual line of sight exemptions in segregated airspace. So if we take a nuclear power plant, for example, that is segregated airspace. We have our systems installed on various nuclear power plants around the world, and our systems have BVOS exemptions because there is no real risk of an airspace incursion by an unidentified aircraft. So you can fly quite easily in those environments. Where we've really focused now with the Civil Aviation Authority is in how do we fly beyond visual line of sight in unsegregated airspace. And this is where the future flight projects come in. So they are government-funded initiatives managed through the Civil Aviation Authority and sort of governed by the Innovate UK and Connected Places Catapult. So we have previously been part of two future flight projects in the second phase, where we were trialing medical deliveries. So one of our projects was delivering COVID vaccinations and also samples and medication from point A to point B. So with our infrastructure, we can link our docking stations together. So you can go from dock A to dock B and back again. So that way we were able to trial how could you go from A to B with a delivery, and does that speed up the delivery of the payload, but can it be done safely and without any human pilot in the loop? And so that was a really, really successful trial. And there's been multiple future flight projects that are currently ongoing that have taken that concept and are developing it further. Some of them are using our technology, some of them aren't. The future flight projects that we are part of at the moment, there's three key ones. First is Project Haddo, where we are installing our systems at Heathrow Airport, with Heathrow as the key stakeholder in that consortium. And obviously, most people would immediately think there is no way you can fly drones around one of the world's busiest airports, but you can. And you can by making it part of infrastructure and giving air traffic control the ability to dictate when and where those drones are operating. By removing the human from the loop, suddenly drones become part of a pre-programmable, very manageable system so that you can conduct runway inspections, light mast inspections, security patrols, and things like that. So by being able to operate our systems in such a complex airspace, now given it's not unsegregated, it is segregated, but obviously it's a very, very high risk environment. If we can prove the safety there, we can prove it pretty much anywhere. So taking that a step further to actually now look at, well, how do you operate in very close proximity where there are more dynamic operations going on? So not necessarily controlled by a single entity, like air traffic control at an airfield, but with a port environment. So our project in-depth with Associated British Ports and Kia Highways is all around installing infrastructure and then enabling drones to perform, or enabling stakeholders to perform inspections, surveys, security, all of these good things that you can do with drones in very complex environments and unpredictable environments like a port. So what we're doing there is monitoring of the condition of highways. We're checking stock volumes on the harbour side. So again, referring back to the Esri platform, so we've been working very closely with Esri, our strategic partner, to develop automated means of quantifying how much stock do you have in a given compound. Using the segment anything model and other AI systems, we're able to instantly calculate you have 70% capacity in a given compound. So your site managers have oversight of their entire infrastructure very quickly, but with data that is being updated on a constant basis, rather than waiting for a satellite to pass over again, or rather than having to get somebody to go out into the field to capture that data. This is just perpetually being captured and updated. So it's proving massively valuable to them. And we're also using AI for detection of unauthorized vehicles within the ports as well, things like jet skis and stuff like that. So it's a really fascinating project to work on. That one there is then being underpinned by our project partner BT, who are providing their 5G infrastructure. And so we can integrate those two infrastructures together, giving our systems much better connectivity when operating in and around the infrastructure. So we can fly a lot closer to structures, but without risking losing communications. And that's what then has enabled us to fly in more complex environments like built up cities and urban environments, which I'll come back onto in a second. And then the third of those future flight projects is Project Skyway, which is a 265 kilometer BVLOS corridor, which spans all the way from Coventry down through Milton Keynes, the Cambridge Oxford Arc, and then on down to Southampton, where again our technology is being utilised for long linear infrastructure and how stakeholders can access the infrastructure to perform ad hoc or routine aerial drone missions on that. And again, there we've got consortium partners like BT who are assisting with the connectivity along that, and Altitude Angel for the unified traffic management. So again, how do we operate these drones in now unsegregated airspace when there could be other airspace users incurring into that space? Again, the benefit of having an automated system is that when we detect another aircraft in the airspace, our system can automatically react to that, whether that's a holding pattern, lowering altitude, or simply changing trajectory based on the trajectory of a passing helicopter or something like that. So again, giving stakeholders the infrastructure, we're very excited to see what can then be developed off the back of this infrastructure. Now that you have it in place, you can use it more readily and you can use that data far more readily.
Indeed. I suppose a final question and thought for you, Mike, before we wrap up is you've obviously now deployed this kind of drone in a box complex, and you've got, as I understand it, a kind of an open air sort of app or front end for the people who want to then effectively book flights or schedule flights in this way. How does that kind of platform work? Because as you say, what you've done here is moved away from, as you say, a regional manager being the only person who can fly a drone on a site to effectively delegating this to, as you've described them, effectively a robotic service, haven't you?
Exactly that. So the way the platform works is whether it's, I'll use the example of Balfour Beatty, for example, where we're working with Balfour Beatty on various sites. We've installed our infrastructure on their sites. Stakeholders who have access to the open air platform simply go on, they define what their requirement is. So draw a polygon or create a waypoint mission. I want to go from A to B. I want it with visual, I want zoom, I want thermal, whatever it is. They put that into the system and they submit that flight request. That then goes through our risk assessment process, where a pilot will vet what has been requested. They'll run the simulation, confirm everything is safe, and then push that out to the real world drone. It will repeat that mission. In a isolated instance like that, where Balfour Beatty and their clients are our stakeholders, there isn't a wider stakeholder community who can access that system. It's very much used dedicated for that purpose. What open air is in its purest form is an automated urban drone infrastructure. So think of a satellite network orbiting Earth, but instead think of a low-level satellite network that can be tasked dynamically and on demand. So you have a dedicated satellite network covering, say, Bristol, where we have launched open air first, that stakeholders can go onto the open air platform, excuse me, onto the open air platform, and they could be a domestic homeowner, they could be a security provider, it could be a large main contractor who requires daily flights on their site for Earth movement monitoring or something like that. They can go onto the platform, they can either subscribe so that they can have high volume flights on a high frequency basis, or they could simply go on a pay per flight basis, simply, again, request your flight. And we've managed to reduce the cost of those flights now because it can be fully automated. There isn't a requirement for any travel to and from site. That cost has been significantly reduced when compared to manual operations. And what's really exciting there is we haven't actually scratched the surface yet of what the potential carbon reduction could be by that type of operation, by reducing the need for people to travel to site, by enabling more people to access real-time information about their locations. You can start to argue that there isn't a need to go back and forth to site anywhere near as often, as well as obviously the clear benefit of removing people from hazardous environments, working at height, construction sites and things like that. And so by creating this infrastructure, what we hope to do is make drone technology accessible to anyone and everyone, and then start to be able to deliver public good. Because once we have the infrastructure installed, suddenly use cases like drone first responder become really, really feasible. So the drone first responder program is quite simple. An incident happens or a 999 call comes in, our systems will automatically deploy to the location of that incident so that the first responders have a real-time view of what is it that they're turning up to. So they can then make an informed decision as to, do we need additional personnel on site, or could we scale back our operations, or do we perhaps need some specialist equipment to come to site? And they have all that information before they've even got close to the incident. And so what our vision is an infrastructure like a 5G network or like a road network that other stakeholders can not only use, but they can then build upon. So we're working with Esri to develop a secondary marketplace for the open air platform as well, where not only can you interact with the drone infrastructure, but you can interact with the digital model that the drones are perpetually creating. Because we have the infrastructure in place, the drones can perpetually be capturing photogrammetry data of the environment, very much like Google Earth, but at a much higher frequency basis to a much more granular level of detail. So photorealistic 3D modeling of building assets for monitoring defects, for example, is something that we are pretty confident that we'll be able to automate in the very near future. So rather than having an ad hoc inspection of a roof conducted, the drones can be programmed to monitor the condition of that roof and then notify a building surveyor when an anomaly is detected. So they're not having to waste their time trying to find the needle in the haystack. It tells you, here's the needle, and then you can make an informed decision as to what needs to be done.
Indeed. I mean, it's been a fascinating chat, and I think what you described very much feels like hopefully the future shape of drone flight, because it feels like a much more controlled, planned activity, as you say, a much more sustainable activity, and also a model that has the potential to scale, which arguably the current model doesn't. And as you say, with the ridiculous situation of a regional construction manager being the only person who can do a drone flight, it does feel that we need to move away from this slightly ad hoc model, which I guess has served the profession very well so far, into a much more structured but also regulated model that helps. And also it's been great to hear how three tech partners are effectively working together when we think of Epic Games providing the visualization for the digital twin, obviously Esri providing that geospatial platform, and then you providing the hardware. So it's great to see how you've built a tech stack, to use the jargon, but by using three tech partners. So it's been fascinating. So for today, Mike, a great chat. Thanks ever so much for your insight, and I look forward to catching up again in the future.
Brilliant. Thanks, Andrew. Really appreciate it.